we are going to focus on backtracking and branch and bound. These two are design techniques for framing an algorithm. Algorithm is a step-by-step procedure for solving a problem. This can be applied for a simple problem or maybe it is a very complex problem. These two design techniques for solving a problem are applicable for complex problems. Complex problems in the sense the problems which cannot be computed easily in a computational period of time, or it might be too vast or many solutions might be there in order to solve the problem. So there are different ways of defining a complex problem. So these two methods, that is backtracking as well as branch and bound, are these methods where it has been used for solving complex problems. So let us look into what is this backtracking and how is it different from branch and bound and what are the different factors involved in. So we have the state space tree construction for both backtracking as well as for branch and bound. So what is this backtracking? Backtracking is nothing but a state space tree is being constructed. So each and every state is being elaborated. So if a solution in the sense satisfying a rule or a condition, that is constraint satisfaction, is being there, then we go or we traverse through that path to get the solution. If it is not going to give a solution in that route, then it is going to get back to the previous node and a different path is going to be traversed in order to get the solution. So backtracking, and there are going to be conditions, so it has to satisfy those constraints. So it is a part of constraint satisfaction problem. So here in the case of branch and bound, it is going to be a optimization problem, or it is going to be a mathematical model for solving such problems. So here also we have a state space tree constructed and we have to look into whether we have to get a maximum profit or it is going to minimize the amount or distance or whatever it is. So depending on what is the optimization factor, we have the problem which is being defined. So here in this constraint satisfaction problem, that is for backtracking, we have the procedure being recursively repeated. That is the same procedure or a function is being called again and again recursively, it has been solved. Whereas in this case, you have a set of candidates, that you have a set of solution, and out of which we have to pick out the best of in case of maximum or minimum. So this is the wider range or like the difference between the approach or the method by which the problem is being solved or the algorithm is being computed. So in the case of backtracking, we have, or it is said that we have to get a solution, a feasible solution. Depending on the constraint, the solution is being updated. Whereas in the case of branch and bound, it is not just a solution, it is the best solution, the optimal solution. How do we get the best of all the solutions is being determined in the case of branch and bound. So very important in branch and bound is we have a bounding factor. A bounding factor, whether it is going to be with respect to an upper bound or lower bound. So upper bound is going to talk about the maximization, the maximum profit. And if it is going to be the lower bound, it is going to be in terms of minimization, the minimum distance or the minimum cost. So that is the bounding function which has influence over the branch and bound. So here in the case of backtracking, it is going to be the decision whether this is the correct path for getting the solution or not. If it is the correct route in which we are traversing, then it will give a solution. If we find out in some path or some like a way that this is not going to be the exact route by which the solution is going to be obtained, then we move on to the previous step and take a different path in order to arrive at the solution. So here the traversal, here we have the depth first search, whereas here DFS, that is depth first search, as well as BFS can be deployed. So the examples or the problems associated with backtracking are N-Queen's problem, Hamiltonian circuit problem, then we have the subset sum problem. Whereas in the case of branch and bound, we have the assignment problem, traveling salesman problem, as well as the knapsack problem. These are the different problems. So here it is getting a solution for each case, whereas in the case of branch and bound, it is with respect to a maximization or a minimization, that is a bounding factor is being influenced and that is being obtained. So here these two types of design techniques are more applicable for complex problems. So algorithms for solving complex problems, this procedure as step by step which are being given to determine the solution for bigger problems are determined by these two methods, that is backtracking as well as branch and bound. Both have the same construction, that is the state space tree is being constructed. Here a solution is being obtained, whereas in the case of branch and bound, it is the best solution, the optimal solution is to be obtained. So here it is the decision which has to be taken according to the constraint to satisfy and get. Here also we have the constraints and decisions which have to go about with, but the bounding factor plays a very important role. So hope you enjoyed watching this and you have learned something, the difference between backtracking and branch and bound for solving complex problems. So happy learning. Don't forget to subscribe our channel, like and click on the bell button. So keep in tune for future videos. Thank you.